Tornadoes, nature's twisting titans. Tornadoes have long been one of the most powerful and unpredictable forces of nature. These violently rotating columns of air, capable of producing wind speeds exceeding 300 miles per hour, are responsible for some of the most destructive weather events in human history. A tornado can flatten entire neighborhoods in minutes, uproot trees, destroy infrastructure, and leave long-term social and economic impacts. While tornadoes have always existed, recent studies indicate that the patterns of tornado activity are shifting. Not only are tornadoes appearing in regions outside their traditional hotspots, but evidence suggests that the most intense tornadoes are becoming stronger, more destructive, and capable of longer tracks. Tornadoes are born from severe thunderstorms called supercells. A supercell contains a rotating updraft, known as a mesocyclone, which stretches downward as a tornado funnel forms. The tornado's intensity depends on the interaction between atmospheric conditions such as moisture, temperature, wind shear, and stability. Historically, tornadoes were largely localized, with short lifespans and limited paths of destruction. However, recent observations show a trend toward larger, more violent twisters. This has raised questions among scientists and meteorologists about the hidden factors that may be fueling this intensification. Understanding these hidden triggers is critical for preparing for the future, as communities face an evolving risk landscape where tornadoes are no longer predictable or confined to traditional regions. The growing power of tornadoes is a reminder that nature's forces do not remain constant. Tornadoes are a product of an intricate balance between energy, moisture, and rotation in the atmosphere. Even slight changes in these variables can amplify their destructive potential. For instance, small increases in atmospheric moisture and temperature can enhance updrafts, allowing tornadoes to reach unprecedented strength. The hidden trigger, climate change. One of the most important yet subtle drivers of stronger tornadoes is climate change. Rising global temperatures and shifts in atmospheric patterns have profound effects on weather extremes, including tornadoes. While tornadoes are influenced by a complex web of local conditions, climate change acts as a background factor that amplifies the energy available to storms. Warmer air holds more moisture, increasing the amount of latent heat that fuels thunderstorms. This added energy can strengthen updrafts, enhance storm rotation, and allow tornadoes to grow larger and persist longer. Moreover, climate change affects wind patterns and jet streams, which are essential for tornado formation. Tornadoes form when winds at different altitudes move at varying speeds or directions, a phenomenon known as wind shear. Wind shear helps tilt the storm's horizontal rotation into a vertical spinning funnel. Scientific studies have observed that extreme weather events, including tornado outbreaks, are becoming more common in certain regions of the United States and globally. While it is difficult to attribute every tornado directly to climate change, the combination of higher atmospheric energy, increased moisture, and altered wind patterns creates conditions more favorable for violent storms. Essentially, climate change acts as a hidden trigger, subtly enhancing the forces that give tornadoes their destructive power. Atmospheric ingredients for stronger tornadoes. To understand why tornadoes are intensifying, it is essential to examine the atmospheric ingredients that make tornadoes possible. Meteorologists often refer to four critical factors: moisture, instability, lift, and wind shear. Moisture in the lower atmosphere provides fuel for thunderstorms. Warm, humid air rising into cooler layers of the atmosphere creates instability, which allows air parcels to accelerate upward, forming strong updrafts. Lift, such as a cold front, dry line, or other weather boundary, forces warm air into motion, creating the initial movement necessary for storm development. Wind shear, the variation in wind speed and direction with height, twists the rising air into rotation, creating the iconic spinning column of a tornado. In recent decades, observations show that lower atmospheric moisture has increased, particularly in tornado-prone regions of the United States. Higher moisture levels mean storms have more energy, resulting in stronger updrafts and longer-lived tornadoes. Additionally, warming temperatures have increased atmospheric instability, providing more potential energy for storms to draw upon. When lift mechanisms such as cold fronts or warm cold air boundaries interact with these conditions, tornadoes can intensify rapidly. These atmospheric ingredients not only explain the formation of tornadoes but also account for their growing strength. Stronger updrafts sustain longer-lived mesocyclones, which can produce tornadoes that cover longer distances and exhibit more violent wind speeds. Larger, more destructive tornadoes are a natural consequence of these evolving conditions. Regional shifts and tornado alley evolution. Traditionally, Tornado Alley in the central United States has been the most notorious tornado-prone region, including parts of Texas, Oklahoma, Kansas, and Nebraska. Tornadoes occur here due to the unique convergence of warm, moist air from the Gulf of Mexico with cooler, drier air from the Rocky Mountains and the Canadian Plains. However, recent research indicates that tornado patterns are shifting. Tornadoes are increasingly appearing outside traditional tornado alley, striking areas that were historically considered low risk. For example, the southeastern United States, which experiences frequent storms, has seen a noticeable increase in violent tornado outbreaks in recent decades. This shift may be due to changes in atmospheric moisture, temperature gradients, and wind shear patterns driven in part by global climate change. As a result, communities in these regions are being forced to adapt to the new reality, the human and environmental consequences. The intensification of tornadoes has profound consequences for human populations and the environment. Stronger tornadoes pose a greater risk to life and property. Entire neighborhoods can be destroyed in minutes, while critical infrastructure such as power lines, hospitals, and schools can be disrupted or destroyed. Extended tornado tracks and higher wind speeds complicate rescue and relief efforts, placing significant stress on emergency services. Communities must adapt to an increased frequency of high-intensity tornadoes, with implications for city planning, building codes, and disaster preparedness. Beyond immediate destruction, stronger tornadoes also affect human psychology. Survivors often experience trauma, anxiety, and long-term stress after witnessing violent storms and losing homes or livelihoods. These mental health impacts, coupled with economic and environmental damage, underscore the broad-reaching consequences of more intense tornado events and the need for communities to invest in resilience and recovery strategies. Preparing for the future. As tornadoes grow stronger and more unpredictable, preparation becomes essential. Advanced warning systems, early detection technologies, storm shelters, and public education campaigns are critical tools in reducing fatalities and injuries. Meteorologists continue to improve predictive models, analyzing atmospheric data such as moisture levels, wind shear, and instability to forecast tornado likelihood and intensity with greater accuracy. Communities can take proactive measures to protect residents and infrastructure. Building codes can be updated to withstand higher wind speeds, emergency response plans can be strengthened, and public awareness programs can ensure that people know how to respond during tornado warnings. In addition, global action to address climate change is crucial for managing the underlying environmental factors that contribute to tornado intensification. Reducing greenhouse gas emissions and implementing sustainable land use practices can influence atmospheric conditions, potentially reducing the frequency and severity of tornadoes over time.